Welcome to part 4 of the Snake video game tutorial in Python. In this video, we're going to talk about controlling animation in the window, and we're also going to add a tail onto our snake, which is an important part of this game because the way the game works is that the snake gets longer and longer when it eats the food. So the first thing that I want to talk about is how the animation runs. So let's run the animation. You can see that we are moving the turtle whenever the player clicks one of the direction keys. And currently I have the food moving randomly when it is hit. But soon what we're going to be doing is adding a lot more turtles into this game, because the snake tail will be made up of an increasing number of turtles, more and more turtles every time the snake eats the food. So that's how we're going to keep track of the length of the tail of the snake. And by adding those turtles, it can really slow down the animation. So one way to speed up the animation is only doing an animation update once every time our game loop executes. So this is important because we are in control of our game in this loop, and we are moving our sprites around. We are controlling the little actors in our game, but we really only need drawing to occur once we've made all the changes that we're trying to make. The Python turtle library allows us to take some control of the drawing by telling it not to do updates on its own, but wait until we tell it to do an update. So what this is going to do for us is this is going to give us some smoother animation. It's also going to give us some control over the speed of animation, as I'll show you in a moment. So the first thing we need to do to take control of this animation is we need to turn off automatic animation, and that's done by changing the value of tracer on the screen, which is the kind of the view window here that we've got access to. It's the object that's doing the listening to the keys, but it also is a way for us to control the animation. So we are going to call the screen tracer 0. By setting tracer to 0, it tells the turtle library that we don't want it to do any automatic updates. So instead, we are going to tell it to do an update at the end of when we've made our changes. So that's down here in this loop. I'm going to add the screen.update. Okay, now controlling this update is going to make our game go much faster, and I'll show you right now. Actually, before I show you that, I'm also going to add an additional state for our turtle. So our turtle has these behaviors of moving up, down, left, and right. Or I should say the snake head. The turtle that forms the snake head can be moving up, down, left, or right. But what happens if I set behave to a value that we don't have yet, like stopped? If we have a state that I don't have a behavior for, then it won't know what to do, and it won't do any of the behaviors. So we can add a stopped behavior where the snakehead actually doesn't move, and so it will bypass all of these different behaviors. So I'm just telling it to start out in this stopped state, and it won't start until we hit one of the direction keys. So this is actually a nice way for the player to wait for the player to start. Instead of right away when we hit the run button, we wait for the player to be ready and then they start the snake moving once they're ready. So I'll show you how that works. If we run, now you can see that the snake isn't moving yet. But when I hit one of the arrow keys, it will move. So I'm going to hit the right arrow key, and so it moves to the right. Now, I don't know if you noticed, but it moved fairly smoothly to the right. And another change that I want to make here is when we move the snake head, we've been moving it forward 5 pixels, a time. We've been moving it forward 5 pixels a time. So I want to move it forward its entire size, because as we add parts to the tail is going to be made up of turtles that are the same size as the head, so I don't want them overlapping. So when I move the head forward, I'm going to move it forward an entire turtle size, which happens to be about 20. So I'm going to move it forward 20. So every one of these behaviors is, instead of moving at 5, is going to move at 20. And now when we run, you can see it's pretty quick. And the speed of the game now is governed by... See, I can't even play it. It's so quick. Oh, I can make it turn around a corner. The speed of the game is governed by how often the updates can happen, and that's governed by how quickly we can go through the main game loop. So in order to control the speed of the game completely, we can add a kind of a delay in here that we control. So there is another library called time that will allow us to add a delay where the program will just stop doing anything and wait for a specified amount of time. And if we add that delay in here, it actually gives us some control over how quickly the main game loop repeats. The way to do that is to use time.sleep. Now, depending on the kind of game you want to create, you can control how fast the game is by changing how long the program sleeps during this time. So for instance, let's say we are going to sleep for 5/100ths of a second. And let's see what that looks like. So it's a little bit more playable. You can see. Still pretty fast, especially for this small space. It's kind of challenging. So what I'm going to do is, I think probably half that speed would be fine. So I'm going to sleep for 1/10 of a second. Yeah, that's nice. Of course, once the game is done and you can play test, this is the place you can go to control the speed of your game. So you now have kind of a handle on how fast your game is, and it works pretty well just by changing the amount of time that it's going to sleep every cycle through. Okay, so we've taken control of animation. Now we are ready to add the tail. We've got the head of the snake is completely working now. The food moves, the snake eats the food. All we have missing in our snake game is a tail. Okay. So in order to create our tail, as I mentioned earlier, I want to have an increasing number of turtles that make up the tail, and they will be similar to the head of the snake, but they will be just kind of following the head of the snake. So I'd like to talk a little bit about what that would look like, or what that's going to look like. Kind of imagine what the snake is supposed to do in our program at different times so that we can think of what kind of programming code we need to write that will make that work for our snake. Okay, so let's say this is the head of the snake, and let's say it's moving this way. Okay. So as we move this way, if we've eaten the food, we would have to add our tail on. So we're going to think about what happens in different cases. Let's say that our snake has a tail of length 2, like this. And let's make the food. Let's make an object that is the food. So we've got a circle here. That is the food. Okay, that's our food. So let's say the food is here. Okay, we're about to eat the food. So currently what happens in our program is that the snake moves and it collides with the food, and then the food is moved somewhere else. Okay, so in this case, let's look and see what's happened. So here's the snake. It's about to hit the food. So if we look at our program, what happens currently in our program is that we immediately move the snake, and then we check for a collision with the food. So actually, the collision with the food is the last thing that we check. So one of the things I'm going to do here is I'm going to actually move the check for collision with the food up here. And the reason I'm going to make it first in our loop is because I'm realizing now that what I do with the snake is going to depend on whether the food has been collided with. So if it's going to depend on that, then I want this to happen first. So let's go back to our drawing. So, okay, let's say we have detected a collision here. So when we detect a collision, the food gets moved somewhere else. And now we have to decide what to do with the snake. So we know we're going to move, we always move the head forward. Okay. And now we have to decide what to do. So we've collided with the food. So what I think we want to do is put an extra piece on the snake tail right here where the head used to be. Right? But we have to know where the head used to be, and that's hard if we've already moved the head. So it looks like what's going to happen here is when we've got the food there, and then we've got the snake head right here, we move the food, and then just before we move the head, we should look at where the head is and then add a piece to the tail right where the head currently is. So it would be right on top of the head. Then we move the head out of the way forward, and now it looks like the snake head has moved forward. So the snake has moved forward, but the tail has grown. So the entire snake has grown. Right? And that's what happens that turn. And now the food's somewhere else. Well, what happens, or I should say not on that turn, but on that pass through the through our program, through our main loop of our program. So on food collision, I'm keeping track of what I'm talking about here. So on food collision, this is what we do, and we do it in this order. First, we move the food. Then we grow the tail by adding a turtle at the front of the tail. Then move snake head forward. If we do it in that order, it's easy because we grow the tail by adding a turtle at the front of the tail. Actually, that's wrong. We don't add a turtle at the front of the tail. We add a turtle. It's important how I word this. We add a turtle right or exactly where the head is. That's important because by wording it like that, I can see that I'm using the position of the head to determine where that piece goes. These turtles, these pieces of the tail, are not actually connected. They only look connected because of the way that we are going to treat them. So the reason I described it like that is by describing like that, it makes it clear to me where I'm going to get the information to do each one of these steps. So moving the food is something that we already did. So we already know how to do that. Growing the tail by adding a turtle exactly where the head is gives me all the information I need. I'm going to put a turtle where the head is because I haven't moved the head yet. Then I move the snake head forward. So that's great. Okay, so now I need to work out what happens when there's no food collision. What happens when there's no food collision? That's the case where we just move the snake forward. So what does that look like? Well, if there's no collision, we know that the snake head always moves forward. So now what we want to do is, it doesn't always move forward, actually. I shouldn't say that, right? Because if you turn the snake, the moment you turn the snake, it could go like this way, for example. Okay, so let's say the turtle is moving this way and you've just turned it, so now it moves this way. So the behavior has changed. So let's see, what do we do? So I think we've got a little bit of the same problem that we had before. We don't necessarily know where this space is. I mean, I guess we could guess that it is 20 pixels in front of where this was, so we could move this forward. But we actually don't know how many turns this snake has gone through. Like, this could be the situation that we're in, right? Where the snake has turned and then the snake turns again. So we have to manage each of these turns. So again, it seems to be important to know where the head was. So on no collision, it looks like what we're going to do is move. So notice that on the food collision, we never moved the tail. We didn't need to move the tail because the tail was growing. So the end of the tail stays in the same place. But now we're actually going to have to move parts of the tail. So I think what we need to do is move the front of the tail to where the head was. And so now we know where, we know where to put it because that's where the head is. And we know we're going to move the head forward at the end of this. We always know that at some point we are move head forward. Same step as this. So we always know we're moving the snake head forward at some point. But we're going to do something before that. So if we put this here first, then we know where to put it. Then when we move the snake head forward, everything's okay. Oh, except that we've got the rest of the tail to worry about. So, and now we don't know where to put this, right? Because we did this. Okay, so it looks like, how do we solve this problem? It looks like we need to preserve whatever is in front of every piece of the tail. We need to preserve that so that we can move the piece of the tail that's behind it. In other words, we need to do this in reverse order. So we need to move the end of the tail first. So we move this to where the piece is in front of it, right? Then we can move this piece to where the piece, I'm trying to overlap them only slightly because I don't want to lose the handle. So then we move this piece to where the head was, or currently is. Then we move the head down. So this effectively, now as long as you've got these things finally lined up, because that actually moves the snake forward, and every piece now knows where it's supposed to go. So it looks like what we need to do is move, starting at the last piece, for every turtle that makes up the tail, move a tail piece to where the piece in front of it is. We've got an additional thing that we did in our steps, is that we ran out of tail when we got here, and we had to move the last, or the frontmost piece of the tail to where the head was. So we can also put here, when you get to the frontmost piece of the tail, move that piece to where the head is. And then at the end, we move the snake head forward. And I believe that's going to work. Let's try it again. We can move this piece to where that is, that piece to where that is, that piece to where the head is. And then in the end, we move the head forward. And then the snake has moved forward. And that's what we have to write, but in code. All right, so these are our two cases. On food collision, we are going to move the food first. So let's look at our main loop. Okay, so we check if the snake ate the food. We are increasing the score. We're printing the score. I'm actually going to right now comment out all the places where we are printing debug strings to the console, because it slows the program down. So let me just get rid of those by commenting them out for now. You can always keep comments in your program that are debug print statements and comment them out so that when you need them, you can uncomment them. Okay, so what we need to do is, in our main loop, we need to first check whether the snake ate the food. And if it did eat the food, we're increasing the score. It looks like we're moving the food, growing the tail by adding a turtle exactly where the head is, and then moving the snake forward. So here's the code that moves the snake forward. So the only thing that we're missing is grow tail. Okay, so by having grow tail in here, I'm saying that I'm going to write a function that does what this right here says. So now sometimes we have not collided with the food. When snake ate food, returns false. So we're going to put an else condition in this if statement. The if statement will only do this if snake ate food returns true, but it will do this if snake ate food returns false. And in this case, let's look at what we are doing. So we are going to do something starting at the last piece for every turtle that makes up the tail. Move the tail piece to where the front piece is. When you get to the frontmost piece of the tail, move that piece to where the head is. Then this is the same as the last step in our true condition, move snake head forward. And the snake head is being moved forward after this if statement. So that's going to happen no matter whether if snake ate food is true or false. So we don't have to worry about that last step. This is a step we do have to think about, or these two steps. And together, if I put these things together, what these things make up is moving the tail forward. So it looks like we have a head and we have a tail. And sometimes we grow the tail, and sometimes we move the tail. Okay, so right now, what we should have in this main game loop is all the code we need for this to work. But what remains for us to do is write the routines that grow the tail and move the tail. And I'll discuss how to do that in the next video.